Welcome back to all. In today's session, we'll find moment of inertia of a T-section. So let us get started. Calculate the moment of inertia about its centroidal axis of a T-section about both the axes. Assume flange 180 into 12. So this portion here is my flange. This yellow portion is my top flange here. So its dimension is given equal to 180 mm width, and then its depth is 12 mm. Vertical wave 150 into 18 mm. So its depth, this orange part here is my web portion, and its depth is given equal to 150 mm, and its width is equal to 18 mm. And now we are asked to find moment of inertia about both axes, x-axis as well as y-axis, and also we have to find radius of gyration about both the axes. So I'll just draw a small diagram here. So about this plane I'll have x-axis, and about this plane I'll have y-axis plane. So let us solve the numerical and find moment of inertia about. So let us first find moment of inertia about x plane. Now here again, as we talk about x plane here, x plane will be running in this direction here. So if this is my x-axis here, this top flange is running parallelly with this x-axis here. So if I have to find moment of inertia about this x-axis, I'll have to use a parallel axis theorem. So let us do one thing. In I section, the numerical is similar to I section, and in I section what we have done, we have gone as section 1 and section 2, and there was bottom flange here, and then for that we went as section 3. So today's in this case, let us go 1 and 2. You can go either way. If you make this 1, it is fine, and 2, this is also fine, and you can even make this section. I'm making the web portion as section 1 and the flange as my section 2. So you can solve it either way. So today I'm gonna go from bottom to top. So if I go from bottom to top, I'll have to use a parallel axis theorem. So before we go apply the parallel axis theorem, let us find its area and its height h, right? So my area 1 will be equal to A1 will be equal to area 1 for this web portion here will be equal to 150 into 18. So this will be coming equal to 150 into 18. So this is giving 2700 mm square. So area 2 for my second section here, area 2, which is A2, will be equal to 180 into 12. This will be coming equal to 180 into 12. So it's coming 2160 mm square. So we have found both A1 and A2. Now let's find out Y1. Y1 for this web section will be half of this till y1 will be from here to here, half the distance of this web. So this will be my y1, and this will be coming equal to 150 divided by 2. This will come equal to 75 mm, right? Next, let's find y2. Now, since I'm going from bottom to top, I need to go all the way from bottom till half of this section 2. Half of this section 2 will be from the half of this flange here. So till here I have to go. This will be my y2 distance, y2. So to find y2, I have to add the whole depth of the web, which is equal to 150 plus half the depth of my second section or the flange portion, that is 12 by 2. So this will give 150 plus 12 by 2 is 6, so it will be equal to 156 mm. So I found both y1 and y2. Now let's find out y bar. Let us see at what distance the exact crossing of my x-axis and y-axis centroid cross each other. That distance, let's find, which is equal to y bar equals to a1 y1 plus area 2 y2 divided by area 1 plus area 2. So this is the formula. How much is my area 1? Area 1 is 2700 into y1 is 75 plus area 2 is equal to 2160 into y2 is equal to 156 divided by 2700 plus 2160. So let us see how much we get. So it will be equal to 2700 into 75 plus 2160 into 156 divided by 2700. This is the total area. So this is coming equal to 111 mm. So I find my distance y bar also. Now it means that the distance if this is my y1 distance, and if my from y1, if this is the total depth of the web is 150, so my y1 at this distance, it was coming equal to 75, and this distance here y bar is coming 111. So we can take about somewhere around here. So my x-axis passes somewhere around here, x-axis, and y-axis from somewhere from here. Let us see, y, right? And this centroid G from this portion here, from this portion till this point here, centroid G, my distance is coming equal to, y bar is coming equal to 111 mm. Since we are making the section from the bottom, so we need to go from the bottom. If you have made section from the top 1 and 2, if you find this y bar distance would come different from the top portion. You can try the calculation, but I'll just explain you here simply. If you find y bar from top portion, the distances of this y1 and y2 will be different, and hence you will get a different y bar from if you come from top to bottom. Since I went from bottom to top, I'm getting y bar is equals to 111 mm. Now let us find moment of inertia about Ixx. So if I have to find moment of inertia about Ixx, will be equal to Ixx1. Ixx1 here is the moment of inertia of my first section, that is the web portion, plus Ixx2, moment of inertia of the second section, which is my flange portion of the T section. So if I further find Ixx1, it will be equal to BD cube by 12 plus, now I need to use a parallel axis theorem, so it will be A1 H1 square. So this is my Ixx1 plus, for Ixx2 I'll also have BD cube by 12 plus A2 H2 square. Now let us put the values. Let us see. For Ixx1, which is this section here, my B for the web portion is 18 and its depth is 150. So I have 18 into 150 cube by 12 plus, how much was my area 1? Area 1 was 2700 into height would be equal to H1. H1 will be equal to y bar minus y1. So how much is my y bar? Y bar is equals to 111, and y1 was equals to 75. So I have 75 square. So I have all my values here, plus now for the second portion, which is the web portion here, which is the flange portion here. This second section here is my flange portion here, so its width B is equals to 150 mm and its depth is 12. So my B is 180 into, and its depth is 180 into 12 cube by 12 plus, how much was my area 2? Area 2 we found it equal to 2160. So area 2 is equals to 2160 into, now my H2 will be equal to y bar minus y2, right? So y bar is equals to 111 minus y2 came equal to 156 mm. So 156 mm the whole square. So let us solve this in a calculator and see how much we get. Ixx. Let us open a bracket. Okay, I'm going to do one by one. 18 into 150 cube by 12 plus the area into its height, whole square. So this is coming equal to 8.56 into 10 raised to power 6. So this is coming 8.56 into 10 raised to power 6 plus, this is my Ixx1 plus Ixx2 will be equal to 180 into 12 cube by 12 plus its area 2160 into its distance, which is 111 minus 156, the whole square. So I'm getting 4.39 into 10 raised to power 6. So let's make this value into 4.4 into 10 raised to power 6. So this is coming equal to 4.4 into 10 raised to power 6. So the total will be equal to plus 8.56 into 10 raised to power 6. It's coming equal to 12.95, or we can say 12.96. It is coming equal to 12.96 into 10 raised to power 6 mm raised to power 4. This value is almost approximately equal to 13 into 10 raised to power 6 mm raised to power 4. Right, so now let's find, we have found moment of inertia about Ixx. Now let's find moment of inertia about Iyy. To find moment of inertia about Iyy, it will be equal to moment of inertia of the first section plus the moment of inertia of the second section, which is the web portion, flange portion. So here it will be dB cube by 12 plus dB cube by 12. How much is my D depth for my web? The depth of this web portion is 150 and its width is 18. So my depth is 150 into width is 18 cube by 12 plus, similarly, depth of this flange second section is equal to 12 mm and its width is 180. So it is equal to 12 into 180 cube by 12. So this will come equal to 150 into 18 cube by 12 plus 12 into 180 cube by 12. So this is your moment of inertia about Iyy. It is coming equal to 5.9 into 10 raised to power 6 mm raised to power 4. So I have found both moment of inertia about both the axes Iyy as well as Ixx. Now next step asked us to calculate the radius of gyration about both the axes. Now we need to find radius of gyration. Second, radius of gyration. To find radius of gyration, let's find about the first axis. X-axis will be equal to Ixx by its area. So how much was my Ixx? Ixx was equal to 13 into 10 raised to power 6 divided by its area was 2700 plus 2160. This is the total area. Now let us see how much we get. It will be coming equal to 13 into 10 raised to power 6 divided by its total area 2700 plus 2160. So this is coming equal to 51.72. So this is coming equal to 51.72 mm. So this is my radius of gyration about Kxx. Now about Kyy, it will be equal to Iyy by its area. So how much was my radius of moment of inertia about IYY, it was equal to 5.9 into 10 raised to the power 6 divided by its area, 2700 plus 2160. This will be coming equal to, I'll just change this value here. It is equal to 5.9. So this is coming equal to 34.84. So it is equal to 34.84 mm. So this is my radius of gyration about KYY. So this numerical is over here. I hope it is clear. This is the second question, and for this second question we need to find moment of inertia about both the axes, that is x axis and y axis, and this is a inverted T section, and for this inverted T sections the dimensions are already given. So let us get on with the calculation. So first we need to find moment of inertia about I x axis. So again, if I say that this is my first section and this is my second section, I'm dividing it in this manner again. So if I find, it will be equal to Ixx. To find moment of inertia about Ixx, I still need to apply parallel axis theorem. So it will be equal to Ixx1 plus Ixx2. So before I get on, let us find areas first. Area A1 will be equal to 200 into 12. Let's see how much this will be in a calculator. 200 into 12, 2400 mm square. Area A2 will be equal to 350 into 10. This will be equal to 3500 mm square. So let us find y1 and y2. y1 will be only distance from here to here, from here to here, only half of this. This is my y1 portion, y1. So y1 will be 12 by 2, will be equal to 6 mm. Now my y2 will be equal to, now y2 I need to go all the way from this bottom till half of this width, the half of this width. Okay, so from bottom till half of this width till here will be my y2 distance. So y2 will be 12 plus half the distance of width portion, 2. So this will be equal to 12 plus 350 by 2, 187. So this is equal to 187 mm. Right, now let's find y bar. Y bar will be equal to A1 y1 plus A2 y2 by the total area A1 plus A2. So my area 1 is equal to 2400 into y1 is 6 plus area 2 is 3500 into y2 is 187 divided by the total area. So let's see how much we get. This 2400 into 6 plus 3500 into 187 divided by the total area. So this is coming equal to 100 113.37. 113.37 mm. So we can say that it is from the base, it is lying at around, from here to here, if it is 187, so around here. X-axis will pass from around here, and y-axis from around here, and this is my centroid G, and from here to here the distance is 113.37 mm, which is my y bar distance. Now next, let us find Ixx, moment of inertia. This will be equal to BD cubed by 12 plus A1 H1 square. Parallel axis theorem here, plus BD cubed by 12 plus A2 H2 square. So you get B for this section down here is 200 and D is 12. 200 into 12 cubed by 12 plus area 1 was 2400, and H1 will be equal to y bar minus y1, and H2 will be equal to y bar minus y2. So how much is my y bar? Y bar was 113.37 minus y1 was 6. So y1 is 6 square. So this is my Ixx1. Ixx2 will be, how much is my B? B here is 10, D is 350. 10 into 350 cubed by 12 plus area A2 was 3500 into y bar is 113.37 minus y2 was 187 here, right? So 187 square. Now let us solve this in a calculator. (200 into 12 cube by 12 plus area into its height h minus 6 the whole square plus, now the second Ixx2 also I'm doing it here altogether, 10 bracket open, 10 into 350 cube by 12 plus area into its distance minus 187 square. So this is coming equal to 82.4 into 10 raised to power 6. So my Ixx is equal to 82.4 into 10 raised to power 6 mm raised to power 4. So this is my Ixx. Now let us find Iyy. Iyy will be equal to Iyy1 plus Iyy2. So here simply we need to do dB cubed by 12 for the first section plus dB cubed by 12 for the second section. Now this is my first section here. This section is my first section. So it's D is 12, B is 200, right? So dB cubed by 12, I have 12 into 200 cube by 12 plus. For my second section here, this is my second section, orange portion. Its D is 300 and B is 10. B is 10. So 350 into 10 cube by 12. So let us see how much we get. $12 into 200 cube by 12 plus 350 into 10 cube. 10 cube. It is coming equal to 8.03. It is coming equal to 8.03 into 10 raised to power 6 mm raised to power 4. So this is my moment of inertia about IYY and IXX for a inverted T section. This is it for today's class. See you tomorrow with more numerical.